Hello learners, welcome to our lesson 13 in statistics and probability. And this is all about computing probabilities and percentiles using the standard normal table. So after learning how to identify regions or areas under the normal curve and converting normal random variable to their corresponding standard normal values or vice versa, I think you are now ready, you're now set to apply what you have learned from our previous lessons to this new lesson, which is all about computing probabilities and percentiles. And in this lesson, you will use the C table or the standard normal table, which was discussed from our previous lesson. In this lesson, you're expected to solve problems involving probabilities and percentiles using the standard normal table. So let's get started. First, let's have a background check. So from our previous lesson, you have learned about the standard normal curve. And from your chapter 1, from our previous chapter, we have learned all about probabilities which deal with discrete random variable. So now we will be learning how to determine probabilities when we are dealing with continuous random variables. So probabilities. Do you know that the area under the normal curve can also be thought as a probability distribution if the values are normally distributed? Just like the area, the probability ranges from 0 to 1 or 0% to 100%. The problems involving probabilities can also be solved using the areas under the normal curve and using the standard normal table. This is why you have learned how to identify or find regions or areas under the normal curve and how to use the standard normal table, because you will be using this knowledge in solving problems which involve probabilities under the normal curve. To illustrate how to determine probabilities under the normal curve, let's have here an example. Example number 1, the average household electricity consumption in the country is 248 kilowatt hour. What is the probability that the household consumes less than 180 kilowatt hour, assuming that the electricity consumption is normally distributed with a standard deviation of 56 kilowatt hour? So to solve this problem, we have to follow the steps. So the first step is you're going to identify the given. So from our given situation here, what are the given? So we have here the mean. So when we say the mean, we are also referring to the average. So since the average household electricity consumption is 248 kilowatt hour, so our mean is 248. Then we have here the standard deviation, which is equal to 56 kilowatt hour. And our normal value, or our x, is 180 kilowatt hour. Since we will be looking for the probability, we will determine the probability that the household consumes less than 180 kilowatt hour. So our x is 180. After identifying the given in the problem, the next step is we're going to standardize the normal value. So again, recall our previous lesson in converting a normal value to its standardized value. So we have to use this formula. Again, in solving probabilities under the normal curve, we will be using z-scores or z-values. So we cannot use this normal value under our standard normal curve. So we have to standardize this x or this normal value. By standardizing, again, we have to convert this normal value into its corresponding z value. So we have to use this formula. So simply substitute the given values. So our x is 180, the mean is 248 kilowatt hour, and the standard deviation is 56. So we have here 180 minus 248 divided by 56 is equal to negative 1 and 21 hundredths. So the equivalent z-score of 180 is negative 1 and 21 hundredths. after standardizing the normal value, we have to draw the normal curve indicating the z-value and its corresponding area. So we have to graph our z-score under the normal curve. So we have to locate where is our z-score. So if this is the mean, this is 0. If this is the value of our mean, which is 0, so our z-score is located between, so if this is -1 and this is -2. So our z-score is located between -1 and -2. So it is found here. Now the question is, why do we have a shaded region here? So take note, in our given problem, we are looking for the probability that a household consumes less than. So from our previous lesson in identifying regions, so we have encountered the word less than, how to find the area which is less than a z-score, your normal value. So we will be looking for the probability the probability that a household consumes less than 180 kilowatt hour. So if this is our z-score, this is, take note, this is -1 and 21/100ths, which is equivalent also to 180. So let me put that value. So this is also equivalent to 180 kilowatt hour. Now, since we are looking for the probability which is less than this value, that's why we're going to shade. We are going to find the area which is to the left of this z value. So remember, if it is less than, it is to the right of the z value. So remember that if the values are to the left of the mean, the values are decreasing. So if dito natin makikita ang 180, therefore yung mga values na mas mababa sa 180 ay dito natin makikita, such as 179, 160, down. Yes, decreasing. So the values here are decreasing. That's why ito yung inahanap natin. So we are going to find the area of this shaded region. So after visualizing, what are we going graphing the normal curve indicating the z-value and its corresponding area, the time that we're going to use the z-table to find the area. So why do we have here a positive value, since from our previous step we had a negative z-value? So remember that, again, recall your lesson from our from lesson 12 in lesson 11 in identifying regions, that we don't have negative z values. So we have to consider the positive z value of a given score if it is negative, since, again, recall the characteristic of the normal curve, that what happens to the left also happens to the right. So the values to the left are also equal to the values to the right of the mean. So the area value of this positive 1 and 21/100ths is the same as the area value of negative. So their area value are just equal. Okay, so we are going to use the z table to find the area that corresponds to z, which is equal to 1 and 21/100ths. So that we have the answer there. The area that corresponds to 1 and 21/100ths is 3,869 10,000ths. Why? So looking at the z table, where the first two digits is 1 and 2/10ths. So we're going to look at the rows and find where is our 1 and 2/10ths, and it is located here. 1 and 2/10ths. Next, our third digit is 100. So from our columns, where is our 100? So it is found here. Then after that, we're going to look at the intersection where they coincide. The value and the area value where they coincide is 3,869/100ths. That is why the area that corresponds to the z value is 3,869 10,000ths. Now, after looking for the area that corresponds to our z value, the next step is we can now compute the area. So again, recall, so if this is our z value, which corresponds to -1 and 21/100ths, we are looking for the shaded part. Take note that the area that we have determined a while ago is just the area from the mean up to this z-score. So remember again the lesson in identifying regions under the normal curve, that if we're going to find the area of a corresponding z-score, so automatically it is from the mean up to the corresponding z-score. So again, this is not the area that we're looking for. So this is the area that we're looking for. But if we have identified the area here, it is easy for us to identify the area of this shaded region. So again, it has an area value here from the mean up to the z-score of 3,869 10,000s. Now look at the figure. How can we determine the area of this shaded region? Or which is the area less than the z value or less than 180 kilowatt hour. So it is very simple. So we subtract this area value from the value of our half of the curve, the area value of our half of the curve. Remember that the value of the half of the curve is 5/10. So this comprises, since the total area under the normal curve is 1, so half of the curve, of course, is 5/10. So again, we simply subtract 3,869 from 5/10, which is half of the curve. So by doing that, we have here the probability of z, since we are looking for the probability of z which is less than our z value, or less than what this is also less than to 180 kilowatt hour. So the probability of z which is less than -1 and 21/100 is equal to 5/10 minus 3,869, which is equal to 1,131 10,000. So the area here has a value, this area has a value of 1,131 10,000. So that is the area to the left of this z-score. So therefore, we can now interpret the result as the probability that a household consumes less than 180 kilowatt hour is 1,131 10,000s, or 11 and 31/100%. So this is the probability. So take note that the area under the normal curve is also the probability. Okay, so this is our area which is less than this z-score, so automatically this is the probability. Next, we have here example number 2. The mean number of hours that students spend in the social media per day is 6 and 5/10 hours, with a standard deviation of 1 and 8/10. If the number of hours is normally distributed, find the probability that a random student spend, letter A, we have here, between 4 to 7 hours in the social media. Letter B, more than 8 hours in the social media. And we have another one. Suppose that the school had 1,500 students. How many students spent more than 8 hours in the social media? So we have to solve, we have here 3 problems. And we have to solve each of the problem. We're going to find their probabilities. Let's have first the letter A. We're looking for the probability that the students spent between 4 to 7 hours in the social media. So to solve this, we have first to, what is the first step? Identify the given. So from our previous problem, the mean is 6 and 5/10 hours. So the average time they spent per day, they spent using social media per day is 6 and 5/10 hours. The standard deviation is 1 and 8/10. So from our problem, we have here 2 values of x, or 2 normal values. The first is 4, since we're looking for between 2 numbers. So our x sub 1 is 4 and our x sub 2 is 7. So after we have identified the given, our next solution is standardize the normal value, since again since we will be dealing with the standard normal values, specifically the standard normal curves, and we will be dealing with z-scores. That's why we have to convert these normal values to its corresponding z-value. So by standardizing, we have to use this formula. So first, since we have two scores or two normal values, the 4 and 7, we have here two process or two solutions. For x sub 1, we have here c sub 1. Our x sub 1 is 4. Our mean is 6 and 5/10. Our standard deviation is 1 and 8/10. So you may use your calculator to solve this one or to check if it is correct. So 4 minus 6 and 5/10 divided by 1 and 8/10 is equal to negative 1 and 39/100. So therefore, the z-value of a normal value of 4 is equal to negative 1 and 39/100. So since we have here a negative sign, therefore it is found to the left of the mean. Next, our x sub 2 is 7. So our z sub 2 is equal to x sub 2, which is 7 minus the mean divided by the standard deviation. So it is equal to 7 minus 6 and 5/10 divided by 1 and 8/10 is equal to 0 and 20 or 28/100. It is positive. Since it is positive, therefore it is located to the right of the mean. So next, what do you think is the process after after standardizing the normal values? Of course, we have to graph or draw the normal curve and indicate the z-value and its corresponding area. So again, our 4 has an equivalent z-value of negative 1 and 39/100. So it is found between negative 1 and negative 2. So again, this is our first, we have to use red. This is our first z-value, which is negative 1 and 39. And this is 0 or 28/100, which is equivalent to 7 hours. So again, this is equivalent to 4 hours, and this one is equivalent to 7 hours. Since we're looking for the probability between 4 to 7, that's why the shaded region is between, or the area that we are looking for is between negative 1 and 39/100 up to 28/100. So this is the shaded region that we are looking for. Okay. Next, after graphing and identifying the corresponding area that we're looking for, the next step is we're going to use the z-table to find the area that corresponds to each z-value. So the area that corresponds to 1 and 39/100 is 4,177 10,000s, while 28/100 is an area of 1,103 10,000s. Why? So let's review the z-table. First, again, we have first, our z-value is negative 1 and, or positive, yes, it is positive 1 and, I'm sorry, it is already written, so I may delete this one. So our first z-value is 1 and 39/100. So again, recall how to find the area. So first, we have the first two digits, which is 1 and 3/10. So we're looking for the rows. We will look at the rows and find where is our 1 and 3/10. So 1 and 3/10 is located here. Next, the third digit is 9 or 900. So we will locate at the columns where is our 900. So it is found here. And the last, of course, it is very simple. Look at the intersection where they coincide. So the area value where they coincide has an area value of 4,177 10,000s. That's why the area is this. Next is 28/100. So our first two digits is 2/10. So we will look at the rows and locate where is our 2/10. It is found here. The last digit is 800. So from the columns, we will find, and we have here the 800s. Again, look at their intersection where they coincide, and it has an area value of 1,103 10,000. That's why the area that corresponds to 2800s is 1,103 10,000s. Very simple. I know you have mastered these steps on how to find the area that corresponds to each z value. Next, after finding the areas to corresponding z-scores, we can now compute the area. So observe that this is our shaded region, which is between -1 and 3900s and 2800s. And we have found out that from the mean, the area from the mean up to this point, or -1 and 3900s, and we have also found out the area from the mean up to this point, up to this z-score. Okay, so we have found out that the corresponding areas are here. So the corresponding area of 2800s is this, while the corresponding area of this z-score is this. Now look at the figure. How can we find the area of the shaded region which is between these two z-scores, or between 4, this is a value of 4, this is equivalent to 4 hours, while this one is equivalent to 7 hours. How can we find the area that corresponds, or how can we find the area between them? What is the operation that we can use? Of course, addition is the operation, since we're looking for the probability in between two numbers or two z-scores. So therefore, we will add the two areas. And how can we express this in formula or in notation? So our z-score, we're looking for the z-score or z-value, or the probability of the z-score, which is less than -1 and 3900s, but again, we're looking for the probability of z, which is greater than 1, -1 and 3900s, but less than 2800, since it is between. So if it is between two z-scores, just follow this pattern. Okay, so it is equal to 4,177 10,000s plus 1,103 10,000s, and it is equal to 528,000s. So therefore, the probability that a random student spent between 4 to 7 hours in social media is 528,000s, or 52.8%, or 52 and 8/10%. So almost more than half of the students spent 6 hours, between 4 to 7 hours, with a mean of 6 and 5/10 hours. I hope you get that. So again, this shaded region has an area of 528,000s, which is already the probability, the value of our probability. Next, letter B, more than 8 hours in the social media. So more than is synonymous to greater than. Again, more than is synonymous to greater than. So to solve for this problem, to find the probability that the student spent more than 8 hours in the social media, first, you have to, of course, identify the given. So it's just the same with the given in letter A. But our x is 8, since we're looking for the probability more than 8 hours. Still, the mean and the standard deviation are the same. After identifying the given, what shall we do next? Of course, we have to convert. We have to convert the 8 hours, since we will be dealing with the standard normal curve and we will be dealing with z-score. So we will have to convert this normal value into its corresponding z value. So we will be using this formula. Again, this is our formula. So just substitute the given values to our formula. So our x is 8, our mean is 6 and 5 tenths, and our standard deviation is 1 and 8 tenths. To do the process, 8 minus 6 and 5 tenths divided by 1 and 8 tenths is equal to 83 hundredths. So the corresponding z value of 8 hours is equal to 83 hundredths. Take note, it is positive, therefore it is located to the right of the mean. Therefore, third step is we are going to draw the normal curve and indicate the z value in its corresponding area. So this is our z-score, which is a value of 83 hundredths. Since we're looking for the area that is more than 8 hours, therefore we're looking for the part which is to the right of our z value. So this is the part where we are looking for. This is the area that we are looking for. It's shaded to the right of 8300. Since more than 8 hours, we can find 8 hours, more than 8 hours here, such as 9, 10, so on. So after graphing the z value in its corresponding area that we're looking for, this is the time that we have to compute the area. But first, we have to use the z table to find the area that corresponds to z, which is equal to 83 hundredths. Again, use your z table. So since our z value is 83 hundredths, so our first two digit is 8 tenths, or 0.8 or 0 and 8 or 8 tenths. We have to look at the rows and we have to find where is our 8 tenths. It is found here. Next column, next digit is 3 hundredths. We have to look at the columns and locate where is our 3 hundredths. It is found here. And look at their intersection, where the point or the value where they intersect. And it is found here. So their intersection has an area value of 2,967 thousandths, 10 thousandths I mean. That is why the area that corresponds to 83 hundredths is 2,967 10 thousandths. This is already the area. So since we have the area of the corresponding z-score, we can now compute the area. So observe that from the mean up to the z-score, we have a area value of, so this is the area that we have identified a while ago, which corresponds to the z value of 83 hundredths. And this is not the area of this shaded part, which has a color of light blue. So again, always remember that when we're looking for the area that corresponds to a z value, that means we're looking for the mean. Looking for the area, I mean from the mean up to that z value. So it has an area value of 2,967 10 thousandths. So observe the figure. How can we find this, the area which is greater than or more than 83 hundredths? How can we find this shaded part? How can we find the area of this region? So again, if this is our figure, the process that we will be needing is we have to subtract the area value of our z-score from the total area of the half of the curve. Since the area of our half of the curve is 0.5, we have to subtract 2,967 from 5 tenths. So therefore, the probability of z, which is greater than, since we're looking for more than 8 hours, so z greater, the probability of z, which is greater than 83 hundredths, is equal to 5 tenths minus 2,967 10 thousandths is equal to 2,033 10 thousandths. So we have deducted this area, and therefore the remaining area has a value of 2,033 10 thousandths. Therefore, the area of this region has an area value of 2,033 10,000s. So therefore, we can say that the probability that a random student spent more than 8 hours in the social media is 2033 10,000s, or simply 20 and 3300% or 20.33%. So this is already the probability. The last is, we have here, suppose that the school had 1,500 students. About how many students spent more than 8 hours in the social media? So we are looking for the number of students that spent more than 8 hours. Since we have identified the probability that students spent more than 8 hours, tatanungin naman natin, ilan kaya, given na yung probability natin, ilan naman kaya kung merong 1,500 yung school sa given, sa problem, ilan kaya sa mga students na yun ang spent ng more than 8 hours sa social media? To solve, here is our solution. Since the probability that students spent more than 8 hours is equal to 2,033 10,000s, or 20.33%, we simply multiply the total number of students, which is 1,500, to the probability. So simply get the percentage of 1/5. So 1,500 of 20%, 20.33% of 1,500. Simple as that. So simply multiply, or 1,500 times this value. It is still the same. Is equal to this value. So 1,500 times 20.33%, or 2,033 10,000s, is equal to 304 and 95 hundredths. Remember that students are whole numbers. Since wala tayong student na 95.95, you can round this up. Round up this value to 305 students. Approximately, there are 305 students in a certain school spent more than 8 hours in the social media. So again, we have here the answer. About 305 students spent more than 8 hours in the social media, which is equivalent to 20.33% of the total students. So that is how you solve the problem the last problem in this example number 2. So I hope you get that. Next, we have another one, percentile. Since we're done with probabilities, this time we will be solving problems involving percentiles. So what is a percentile? A percentile is a measure used to indicate the value below, take note, the value below which a given percentage of observations fall. Percentiles are usually utilized to compare scores. So example of these percentiles are in your NCAE. So it is used in your NCAE test results. So after taking the test, they have sent you a card showing your percentile rank in different subjects. So what does this percentile means? Example, if there are 400 of you who took the test, who took the NCAE test, and your percentile rank in math, for example, is 95%, ibig sabihin, 95% sa 400 na kumuha is mababa kaysa sa score mo. So, merong nasa 95%, yung rank mo, yung score mo na 95% which is already the percentile rank. Ibig sabihin, 95% ng kumuha, 95% ng 400 ay nakakuha ng score na mas mababa kaysa sa'yo. Ibig sabihin, nasa taas ka nila. So, yung score mo is mataas kaysa sa 95% na kumuha. So, I hope you get that. So, to illustrate, let's have example number 2. Assuming that the scores of the students in the exam is normally distributed, what is the percentile of the student who scored 94 points if the mean score is 85 and the standard deviation is 12? So to solve this problem, we have to follow the step. Of course, the first step is identify. Always identify the given. So in the problem, We have the mean of 85, so the average score is 85. The standard deviation is 12, and our gross score is 94 points. So we'll be looking what is the percentile rank of 94. 94. What is the percentile of the student who scored 94? So after identifying the given, next step, we will be standardizing this 94, this normal score or raw score, by simply converting it to its equivalent z-score. So again, just use this formula. So to solve, just simply substitute the given values to our formula. Our x is 94, the mean is 85, and the standard deviation is 12. Therefore, 94 minus 85 divided by 12 is 75 hundredths. Therefore, the z-score, the z-value of 94 is 75 hundredths. So after converting, we have to draw the normal curve indicating the z-value and its corresponding area. So we will be looking for the area which is below. So again, since we are dealing with percentile, so it is always below. So the shaded part is below or to the left of this z-score. So since our z-score is 75%, or no, 75 hundredths, or this is equivalent to, remember that this is equivalent to 94. Standardize lang natin siya, and it's given, and its equivalent z-value is 75 hundredths. So observe that the 75 hundredths is to the right of the mean, and it is located between 0 and 1. So therefore, this is our z-score. Now, since we're looking for the percentile rank, ibig sabihin, since percentile rank is the value below of this z-score, so the shaded region is to the left of 75 hundredths. So this is the area, this is the percentile that we are looking for. So to do that, we have to use again the z-table to find the area that corresponds to 75 hundredths. So the area that corresponds to 75 hundredths is 2,734. Why? Take note, the first two digits is 7 tenths. So under the rows, we have to locate where is our 7 tenths. So here it is. And from the columns, we have to locate where is our 5 hundredths. So it is found here. And locate their intersection. Find the area where they intersect. So this is the area value of 75 hundredths, which is 2,734 10,000ths. So the area from 75 hundredths, from the mean up to 75 hundredths as an area, is equivalent to, 2,734 10,000ths. So from the mean yun. So it is 2,734 10,000ths. Observe the figure that since it is half of the curve, so sakop niya yung half of the curve, and we already knew that the half of the curve is a value of 5 tenths. So therefore, we can compute the area. So since the area that corresponds to 75 hundredths is 2,734 10,000ths, and half of the curve, the remaining half of the curve, has a value of 5 tenths. Therefore, what is the operation that we need to use in order for us to find the shaded area or the percentile of the score? So simply add the two areas. So therefore, since we're looking for the percentile below the z-score, therefore the probability of z, which is less than, so less than, below siya. So probability of z, which is less than 75 hundredths, is equal to 5 tenths, or half of the curve, plus the area of 75 hundredths, which is 2,734 10,000ths, and that is equal to 7,734 10,000ths. So this is already the percentile. Thus, the student belongs to the 77th percentile. We simply rounded up, we simply convert this to percentage, or simply multiply this value to 100. So multiply this by 100, and round off to the nearest whole number. So therefore, the student who has a score of 94 belongs to the 77th percentile. Ibig sabihin, 77% of the total students who took the exam are below the score of 94. So, ibig sabihin, nakakuha sila ng score na 93 pababa. So, ibig sabihin, nasa 77th rank na yung score mo. I hope you get the point. Next, example number 4, find the 65th percentile of the normal curve. This time naman, given yung percentile natin. So, hahanapin natin, ano yung score na equivalent is 65th percentile. So, simply as, so we're looking for the z-score, the probability, or the percentile of z, which is less than. It is always less than because we're dealing with the percentile. It is below the value of z. So the percentile of z, which is less than 65 hundredths. So 65th is equivalent to, we have here 65 hundredths. Hahatiin lang natin siya since this is more than half of the curve, therefore it is 5/10 plus 15 hundredths. So since it is more than half of the curve, ibabawas lang natin yung half of the curve. Then yung remaining niya, of course, is 1500. So therefore, this 65 hundredths is equal to 5/10 plus 15 hundredths. After that, we will look for the z value of this area. Since this is the area, this is also the area. So since this shaded region, since it belongs to the 65th percentile rank, so ibig sabihin ang shaded region na to ay may area na 65 hundredths. So, hinati lang natin yung 65 hundredths. So, ibig sabihin, ang 65 hundredths is more than the mean. Of course, alam natin yan na dito na siya, sa mean na siya. So, hahanapin lang natin ano yung z value. Ano kaya yung z value natin dito na may area na 15 hundredths? So, yan yung hinahanap natin. Ano yung z-score or z value na may area na 15 hundredths since alam naman natin na half of the curve, since more than half siya, so half of the curve is already 5/10. 5/10. So, yan yun. 65 hundredths is equal to 5/10 plus this area which has a value of 15 hundredths. So, gagamitin natin dito ang z-table. Hahanapin natin yung area na may value na 15 hundredths. So, saan kaya dito ang area na may value na 15 hundredths? Wala naman. So, kung wala talaga siya, hindi exact yung value niya, hahanapin lang natin yung pinakamalapit. Yung pinakamalapit sa 15 hundredths. So, andito siya. So, dalawa yung malapit. We have here 1,480 10 thousandths. We also have 1,517. So, again, this 15 hundredths is also equal to, may dalawang zero sa magkabila niya. So, this is also equal to, So, erase. This 15 hundredths is also equal to 1,510 thousandths. So, may dalawang zero siya para equal natin siya sa 4 decimal places. So, again, yung mas malapit sa 1,500 or 15 hundredths is this value, 1,517. Since ito, yung distance niya dito is about 20 pa. 20 pa yung distance niya dito. 20 is 10,000. Dito naman, 17 lang. So, 17 lang yung kanyang distance. So, therefore, mas malapit siya dito. And this area has a z value of, we will do the opposite. So, yung intersection niya, it's 0.3 plus 9 hundredths. It's equivalent to 39 hundredths. So, yan yung z-score na may area value na 1517 or 1,517. So, ito siya. So, therefore, the z-score which has an area value which is closer to 15 hundredths or 1,510 thousandths is 39 hundredths. Thus, the 65th percentile of the normal curve corresponds to z, which is equal to 39 hundredths. Therefore, yung value na to, yung z-score natin dito is 39 hundredths, which has a percentile rank of 65 or 65th percentile rank. So, I hope you get the process. Next, let's have another one. What if less than half of the curve? So, find the 38th percentile of the normal curve. So, we're looking for the percentile of C, which is less than 38 hundredths. Therefore, since hindi siya umabot, since it is less than the half of the curve, we simply subtract 38 hundredths from 5 tenths. So, again, this area has a probability or as a value of 38 hundredths. Now, we will look for the z value which corresponds to this point. This point where the shaded region, this point where the starting point of the shaded region. So, alam naman natin na 5 tenths, bawas lang natin, ibabawas natin yung 38 hundredths na to from half of the curve para malaman natin yung area from this point up to this point. So, from this point up to this point, para malaman natin kung ano yung z-score dito. So, from the mean up to this point. So, it has an area of 12 hundredths. So, from the mean up to this point has an area of 12 hundredths. So, hahanapin natin ano kaya yung z-value ng point na to or ng score na to. So, gagamitin natin ang z-table. So, from our areas, ano kaya yung yung area value na malapit sa 12 hundredths or simply 1,200 10,000s. Ano kaya yung area value na malapit dyan? So, ito siya. Ito yung value na malapit sa ating area dito. And it has a z-score value of still from 0.3 row. So, it has a z-score value of 31 hundredths. So, therefore, thus, the 38th percentile of the normal curve corresponds to z. This is z. Z is equal to, this is z, equal to negative. Why negative? Because it is found here to the left of the mean. Since this is the mean, so andito siya sa left ng mean natin. So, negative 31 hundredths. So, this is our z-score. The z-score na may percentile rank na 65th or 38th percentile rank has a z-value of 31, negative 0 and negative 31 hundredths. So, again, if it is less than half of the curve, simply subtract the area value or yes, the percentile from 5 tenths and the remaining area, yun yung hahanapin natin sa z-table. Hahanapin natin kung ano yung area, kung ano yung z-score na may malapit, na may value, na may area value na malapit dito. So, just recall this slide. I hope you get the point. So, it's your turn to answer activities under the activity proper, and do not forget to write your reflections in your reflection journal. Thank you for watching and happy learning, everyone!